I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic on antenna radiation mechanism and isotropic radiator for the course antennas and wave propagation. Now we are coming to the recap of the previous concepts: electromagnetic waves, antenna fundamentals, and here the electromagnetic waves are the time varying fields which propagate through space at the speed of light. They carry energy away from the sources. And now coming to antenna fundamentals, antenna act as a transition device or transducer which converts the guided wave into free space wave at the transmitting side, and at the receiving side it converts the free space wave into the guided wave. So antenna can be defined as a transducer between a guided wave and free space wave and vice versa. So consider a transmitter which generates electromagnetic power to transmit, and this will be as a guided wave propagate through a transmission line, and from the transmission line we need a device which convert this incoming guided wave to the spherical wave suitable for free space wave propagation. Now the antenna do this work, converts spheric guided wave into free space wave and vice versa at the receiving side. So radiation patterns are fundamental properties which provides the spatial distribution of the radiation with respect to direction. So now we are going to discuss this antenna parameters and the isotropic radiator in design thinking way. So now first see the empathy part. So empathy part, we must know what is the useful for the theoretical reference radiator. So since we know that isotropic radiator is a theoretical antenna which is does not exist in practice. So the need of this isotropic antenna is the real antenna exhibit directional properties. Performance comparison requires a standard antenna, and mathematical analysis needs simplified models, and engineering design demands reference matrices. So in order to overcome all these needs, we need a reference lossless 100% efficient antenna, which is a isotropic antenna. So isotropic antenna is a lossless radiator. It is a hypothetical point source, radiates electromagnetic energy equally in all directions with uniform intensity. And if we see the ideal characteristics of the antenna, it has zero physical dimensions, lossless operation, and spherically symmetric radiation pattern in three-dimensional space. So its importance is used as a theoretical antenna and also for gain calculations. So now its mathematical representation, we can calculate Poynting vector or power density from the expression S equal to Pt by 4 pi r square. Here Pt is the transmitted power, r is the distance between the transmitting to receiving antenna. So another important parameter with respect to isotropic radiator is the radiation intensity U, which gives Pt by 4 pi r. So here antenna radiation for isotropic antenna is assumed uniform in all directions. So its key property, the radiation pattern is perfect sphere, directivity is equal to 1, it is lossless antenna, gain is also equal to 1, which can be useful for reference antenna. Its beamwidth is undefined because it provides omnidirectional pattern. Finally, polarization is not applicable to this antenna. So radiation mechanism visualization, we know how the antenna radiates. In the diagram, we have a transmitting side, transmission line, and an antenna. Here antenna is a transducer at the transmitting side and also at the receiving side. So for this isotropic antenna, the wave expand uniformly in all directions, and the energy propagates to infinity following inverse law. So now design thinking, ideate and prototype part. Real versus ideal comparison, isotropic antenna is very much useful because all the antennas, they always have directional properties. So to compare real antenna with ideal antenna, we need isotropic antenna. So practical applications, it's a reference standard for gain calculations. Link budget analysis also, this isotropic antenna is very much useful because to calculate received power we need this antenna. Next is assessment. So key takeaways from the summary part. So far we have discussed the antenna definition. Isotropic antenna is a hypothetical point source uniform radiation, and its mathematical expressions we have seen its radiation intensity and also power density or Poynting vector. And also we have analyzed various properties of isotropic antenna and its real world example. References. Thank you.